partial pressures and known quantities. I think by that he probably means measurable quantities. So which step is ethane chemisorption? First step. Okay. Is it reversible or irreversible? Reversible, right? Okay. So the rate of that reaction is equal to what? Okay. C. We're going to do pressures. It says do pressures. So the pressure of what? RH. What else? Either one. Okay, negative C. And what's that? You can do it either way. You can either do K negative C, or you could put, instead of this, you could write it as Kc and then pressure RH star squared minus
why do you have RE if there's no E term? Yeah. Why wouldn't you just call your rate determining step the third step, right? So when you say RE.
I don't know. I'm just following what he had here. Again, it's from an old test.
Well, I don't like it.
Well, you don't have to. If you want to write down 3 in your notes, I'm not going to look over and like tell you no.
Well, this is the first.
Yeah, it's the first one.
This, I think what he means by this is just rate of ethylene production, which is equal to the rate of this first step. Because it is the rate limiting step. So the net rate of ethylene production is equal to the rate of step 1. I'm seeing confused faces, and that is not good.
The net rate of the total reaction should be the rate of the rate determining step.
Technically, the net of the reaction is equal to the net rate of all the reactions.
Well, right, but they should sum to the rate of the rate determining step.
Yes. What'd you say?
You're saying that just like there are 4 reactions before, you would not put out.
No, I get it. It's weird that it's E because this kind of looks like step E because it has the E's there. But again, I didn't come up with this nomenclature. He just what Jason means in this solution is simply the rate of ethylene production. Okay, but anyways, this is Kc, big K, right? Okay, so are we done? Okay. These are not known quantities, right? This is not a known quantity, this is not a known quantity, so you would get in trouble. You would be ignoring the known quantities part of the question. Okay, so if this is rate limiting, what can I assume about the other equations on the board? Okay, how does that help me? Yeah, those net rates are equal to 0, but don't, you guys love doing that. If you guys see the word equilibrium, don't write down the rate equation. Write down the equilibrium constant. I know that you can get one from the other, but just go straight to the equilibrium constant. So we have some equations that we can use, yeah.
Oh, and then you do like the balance on the sides.
Yeah, you're a little ahead of us. Let's just start with, let's get rid of H star. So what equation can I write down that has H star and relates it to known quantities? The last one, right? So what is the definition of K minus H? Products of a reactant, so the pressure of hydrogen
You know, that's kind of weird. Because it's K negative H. This is this product of
No, he's writing that. Remember, K with a gas phase indicator usually means for adsorption. So he's putting negative H because he wrote it as a desorption.
Why can't you use this?
So I don't think it's weird. I think that actually makes sense to me. But I would have probably just written both of these steps as adsorptions. But he didn't want to confuse people because people look at it and they want to add up the steps and see the total reaction. They don't want to add up the negative of one step. Yeah.
Why can't you use the second one?
The second one, because this is an adsorbed species. This doesn't relate it back to known quantities. We are going to have to use that one, but it's just nicer to just... Okay, so anyways, I can rearrange this. H star is equal to pressure hydrogen to the 1/2 star divided by equilibrium constant for desorption to the 1/2. And now I can plug that into here. Okay, what about R? This is your moment to shine.
2.
Yeah, that one we want to use the second reaction. Why? It's the only one that has R star, so it's kind of obvious. It's the only one we can use. All right, so big KR is equal to what? Concentration of E star, H star, divided by concentration of R star, star. Rearrange. Did I do that correct? I think so. Okay. What's in here? Are all of these known quantities? Are any of them unknown? Which ones? E star. What about H star? I've already dealt with that. There's nothing wrong with plugging this in to here and into here. That is fine. Just don't plug an equation into itself. All right, so we need something for E star. What are we going to use? Yeah. Again, don't use 2. You already used it. So this goes all the way back to, I don't even remember the topic, but in energy balances where you get to write down the number of things you know and the number of things you don't know. Degrees of freedom analysis. So you can't use the same equation twice. So now we're on to the third equation. K minus E is equal to what? Pressure of ethylene, concentrations of vacancies divided by concentration of E star. Okay. I'm really hoping that he did what I wanted him to do. He did. Good. Let's plug all of this in. I'm not going to show the algebra. I don't want to erase this, but I already did. So. I think in part B it says, assume a different step is rate determinative. Not very inventive, but effective. All right, anyways, rate of this step, I won't put RE. Notice that he has decided to switch to this term. You should have been using all along, if you ask me. Okay, any questions? It's just algebra. I know I did a lot of it in one step, but it's only algebra. Now what do I do? Site balance. Okay. What is it?
L squared.
Wait, Why are we squaring it? I'm not solving for star
Oh,
squared.
not star, okay.
L
Minus E star.
minus E star minus, I'm going to say A. I don't think there's an A. R, there was an R. H. Anything else?
I don't remember those species.
Huh?
I don't remember any other bound species.
I don't think so. I mean, there was, the alkane didn't adsorb, right? It dissociatively adsorbs the alkane RH. So then you make R, you make E, and you make H. That's it. Okay, more algebra that I am skipping over. Just like I said before when we did that example for water, sometimes what you end up with over here can be a complex expression representing the coverage of a species. In this case, which term does this represent?